Welcome to College Algebra Notes for Section 4.1. Our learning objectives today, we want students to be able to evaluate exponential functions, both with bases of things like 2, 3, 4, and also with bases of e. And then we also want you to be able to graph those exponential functions again, with a regular base and with our base of e. All right, so f of x equaling b to the x is a basic exponential function. Our requirements is that b has to be a positive value and it cannot be 1. The reason we have the 1 restriction is that if you take 1 to a power, it's always going to be 1. So it doesn't grow at all. You need a base other than 1, but still something positive for it to be exponential growth. So we're going to look at a few basic ones. We're going to start with f of x equaling 2 to the x. And let's go ahead and use x values from -3 up to +3. All right, and let's start with our easy ones. 2 to the 0, anything to the 0 is 1. 2 to the first power would be 2, 2 squared would be 4, and 2 cubed would be 8. And if we look at negative powers, when we raise something to a negative power, remember it just gives us the reciprocal. So 2 to a -1 is going to be the reciprocal of 2 to a +1. So instead of a 2, we have a 1/2. Instead of a 4 here, we are going to get 1/4. 2 to the -2 would be 1 over 2 squared, or 1/4. And then instead of getting an 8 here, we are going to get 1/8 here. All right, let's try graphing it. At -3 for x, we are only up 1/8, so we're going to be very close to that x-axis. At -2, we are up 1/4. At -1, we're up at a 1/2. At 0, we are up at a 1 for y. When x is 1, we're up at 2. When x is 2, we're up at 4. And when x is 3, we are up here at 8. So you can see that it's a nice, smooth exponential growth curve. All right. Our second one, we are taking f of x to the 1/2 power. Sorry, we're taking 1/2 to the x power. Again, let's start with -3 to +3. All right. 1/2 to the 0 is 1. 1/2 to the first power stays 1/2. 1/2 squared would be 1/4. 1/2 cubed, you cube the 1 and the 2, we get 1/8. And then remember, negative powers just give us reciprocals of what we got with the positive ones. So 1/2 to a -1, the negative's going to flip that 1/2 over, make it a 2. 2 to the first is 2. 1/2 to a -2 power is going to flip that 1/2 over and square it, giving us a 4. To a -3 power is going to flip it over and cube it, giving us an 8. So this time at -3, we are up here at +8. At -2, we are up at 4. -1 gives us a 2. 0 is 1. Over 1 up a 1/2. Over 2 up a 1/4. And over 3 up an 1/8. So same idea. This would be called exponential decay because it is coming down as we move to the right. The first one over here was an example of exponential growth. Now, a couple things to notice. They asked us to state the domain and the range. When we look at this, domain for both of these cases is all real numbers. So -infinity to +infinity. And our range for both is everything above the x-axis. If we had extended this out further, in other words, going to 4 or 5, etc., we are getting numbers closer and closer and closer to that x-axis, but we will never actually touch it. So our range goes from 0 to infinity. Notice the rounded brackets, meaning we don't actually touch the x-axis of 0. Notice our bases here. Our first example, our base was 2 raised to the x power. In our second example, our base was 1/2 raised to the x power. The only difference in our graph is that it's a reflection over the y-axis. So reciprocal bases here, our graphs are just reflected over the y-axis. The asymptote for both of these, because we talked about our graph coming down and approaching the x-axis but not touching it, we do have an x-axis, or a y equals 0 would be the equation for that, would be our horizontal asymptote. All right, let's try one more of these. This time we're looking at f of x being negative 3 to the x. And I want to clarify that negative is outside, so we are just taking 3 to the x, and then we're going to make them all negative answers. All right, once again, let's go from negative 3 to positive 3. All right, negative 3, or I should say negative 3 to the x power. So 3 to the 0 is 1. The negative in front is going to make it negative 1. 3 to the first power is 3. The negative in front will make it negative. 3 squared would be 9. We get a negative 9. 3 cubed is 27. Our negative in front makes it negative. Our negative exponents are going to flip this over. So instead of a negative 3, we're going to have a negative 1/3. Instead of a negative 9, we have negative 1/9. And instead of negative 27, we have negative 1/27. All right, that one's going to be pretty tiny to graph, but we should just recognize that over here at negative 3, we are almost down at the x-axis, sorry, just underneath at negative 1/27. All right, at negative 2, we're at negative 1/9, again, very close to that x-axis, just slightly underneath it. At negative 1, we're at negative 1/3. 0, we're at negative 1. 1, we're at negative 3. 2, we're at negative 9, and a negative 27 is off our graph. So all that this negative has done is it's reflected it over the x-axis. All right, so then we're going to transform these. We're going to start shifting them left, right, up, down, stretching, compressing, that kind of thing. Think about our transformations from the past. An a value in front caused either a vertical stretch if it was bigger than 1, or a compression if it was smaller than 1. And if it was negative, it caused it to reflect, like we had on that last one, reflect over the x-axis. All right, the h value is our left and right shift, and our k value is our up and down shift. So what we want to do when we're graphing these exponential ones that have been transformed, we want to graph the parent function. And on a test, I would expect to see that you've graphed the parent function first, and then we're just going to shift our points based on the transformation. It says to graph and label any asymptotes as well, and to list the domain and the range. So looking at this, our parent function would just be 3 to the x. What we've done to it, a positive 1 is going to shift it to the left 1, and the negative 2 is going to shift it down 2. All right, so let's go ahead and graph the parent function. These are our values of just plain 3 to the x. We'll make a little t-chart here. Let's just go from negative 2 to 2 on this one. So 3 squared would be 9. 3 to the first is 3. 3 to the 0 is 1. 3 to the negative 1 flips it over, makes it 1/3. A negative 2 exponent is going to flip it and square it to be 1/9. So let's plot those points. Negative 2, 1/9, negative 1, 1/3, 0, 1, 1/3, and 2/9. And then we are going to shift them left 1 and down 2. So this last point that I graphed here is going to go left 1 and down 2 and land there. Our next one, left 1, down 2, lands there. The point that was there, left 1, down 2. We go left 1, down 2, and left 1, down 2. And you'll notice that because we shifted it down 2, our horizontal asymptote is also going to move down 2. So we have an asymptote here. Our graph is going to go like this. And our domain is all real numbers. We can use anything for our x's. Our range, though, because we've shifted it down 2, we are now going to be starting just above -2 and continuing to go up to infinity. The equation for my asymptote here would be y equals -2. All right, our next example. Our parent function would just be y equals 2 to the x. What we are going to do to transform it, our -1 there means we have moved right 1. Our -5 means we are going down 5. So if you want, you can go ahead and put that asymptote in at -5. We know that that's going to be our cutoff down here. We are going to start with our parent function points using 2 to the x. All right, 2 squared is 4, 2 to the first is 2, 2 to the 0 is 1. Flipping them, we get 1/2 and 1/4. So again, we're going to plot those parent function points. And then we are going to shift them right 1 and down 5. All right, right 1, down 5. All right, so our graph has moved down here, leveling off just above the line y equals -5. So once again, domain is all real numbers. Our range this time, we are starting just above the -5 mark and going up from there. All right, next one. We have y equals 3 to the -x. And we said negative exponents really just flip this over. So this is the same as saying 1/3 to the x power. All right, let's make our t-chart. All right, so 1/3 squared would be 1/9. 1/3 to the first is 1/3. 1/3 to the 0 is 1. A -1 is going to flip this back over and make it a 3. A -2 is going to flip it and square it, making it a 9. So at -2, we're up here at 9. -1, we're at 3. 0, we're at 1. 1, we're at 1/3. And 2, we're at 1/9. So this one hasn't been shifted left or right at all. We're just looking at reflecting it over the x-axis. That negative here basically caused a reflection over the x-axis. So if we look at the one right above it, we had this 3 to the x as our parent function right here. We could have taken those points that we just got right here and just flipped them over the y-axis, and we would have gotten the same picture we have down here. Domain, all real numbers, -infinity to infinity, and range, we are staying above the x-axis, so 0 to infinity, open brackets. Our asymptote here would be y equals 0. All right, our last one here. We have 1/3 times 3 to the x. So our parent function is again just that 3 to the x. However, we have this 1/3 in front. This is going to cause a compression, a vertical compression. So we're going to start with our 3 to the x points, the same ones we had back in that first example here. So we're going to take these same values that we had here and transfer them down. So we had 1/9, 1/3, 1, 3, 9. And what we're going to do is we're going to compress them. So let's go ahead and start. We have -2 is 1/9. Then we're at 1/3. We're at 1, 3, and 9. And the 1/3 in front is going to cause all of my y values to become 1/3 as high as they were. So instead of being up here at 9, 1/3 of 9 is only 3. So I'm going to move down here. Instead of being at 3, 1/3 of 3 is just a 1. All right, so all of my points are just getting compressed. Here I was at a +1. A third of that would only be 1/3. Our 1/3 becomes 1/9. Our 1/9 becomes 1/27. We're getting really, really close to that x-axis, but not actually touching it. So what happens is our graph just becomes more shallow looking. It's not quite as steep of a graph. All right, so the vertical compression caused our y values to get multiplied by 1/3. All right, domain, all real numbers. And our range, we're staying above that x-axis, so above 0. All right, the last two that we're going to look at have a different base. We've used bases like 3s and 2s, pretty common bases for exponential graphs. Our last couple here involve a base of e. E to the x, our e is called our natural base. And e to the x is used in many exponential functions, especially when we talk about growth in nature, such as population growth, both for humans and animals. Our e value is approximated by the function y equals 1 plus 1 over n to the nth power as n goes towards infinity. So as n gets larger and larger and larger, we get values that approach this. Okay, so e is kind of like pi. It's a number. We just have a letter in there as to save space as a symbol for it. So pi is 3.14. E is defined to be about 2.718. So when we graph this and our base is e, that means we're really looking at graphs similar to the ones we just did, where our base was 2 or 3, because 2.718 is in between 2 and 3. So our graphs should look very similar. We're just going to have some decimal values instead. So let's go through from -3 to 3 again. And go ahead and pause the video and just take e to those powers. You have an e to the x key on your calculator. So for example, e to the first, we should get 2.718, or about 2.7. We'll just round. E to the 0 is going to be 1 again. Go ahead and pause the video and fill in the rest of them. All right, checking. Let's go with decimals. We've got e to the third is about 20.086. So we'll graph it just above 20. E squared would be about 7.389. Filling in here, e to the -1 is 0.3679. E to the -2 is 0.1353. And e to the -3 is 0.0498. So again, very small numbers to our left here. So -3, we're not even to 0.05. So just above the x-axis. Same with -2, slightly higher. -1, we're at about a third. 0, 1. 1 is 2.7. So just under our 3 mark there. A 2 is going to be just a little bit above 7. And at 3, we're off our graph at 20. So again, very similar shape to that one we had for y equals 2 to the x or 3 to the x. Domain, all real numbers. And range, again, we're above the x-axis, so 0 to infinity. Our last one here, we're going to take those same points that we just graphed, but we are going to transform them. This one is shifting to the right 2 and down 3. So go ahead and pause the video. I want you to plot the same points that we just graphed on our previous one, and then shift them right 2 and down 3. All right, so starting points, we were really low here, about a third here at 1, just under 3, and just under 7. Or sorry, just above 7. All right, we're going to take those points and we are going to shift them right 2 and down 3. All right, so asymptote is going to shift down 3 as well. So y equals -3 would be our horizontal asymptote. Our graph is going to level off just above that asymptote. Our domain is -infinity to infinity, but this time our range we have shifted down and we are going just above -3 and then on up. All right, so your assignment for section 4.1 is questions 17 through 30 and 35 to 43 odds.